Good day, my name is Mark Jasaldington from the College of Computer Studies, and for today I will presenting to you hybrid machine learning models for long-term stock market forecasting, integrating technical indicators by Francis Fozap, published in 2025 from the source of Journal of Risk and Financial Management. So let's start for the overview of the study. The research tackles the challenge of accurate The research tackles the challenge of accurately forecasting long-term stock market trends. This is crucial for financial risk management, investment decisions, economic stability, and advancing financial technology. The dataset used includes daily S&P 500 from data from 2010 to 2024, providing a rich foundation for model training and evaluation. Next is the ensemble method used. The study applies a hybrid ensemble technique combining LSTM and CNN LSTM model. So the LSTM captures long-term sequential patterns while CNN extracts short-term features from technical indicators. This complementary approach improves predictive accuracy beyond what traditional models can offer. The implementation includes pre-processing, feature extraction, and merging outputs into a fully connected layer for final prediction. Next is the dataset use. So the dataset use was trained by the model on 14 years of S&P 500 data, including daily closing prices and trading volume. Derived indicators like MA, RSI, MACD, and Bollinger Bands were used. In train test split, 80% were used for training set and 20% for test set. So this to ensure that the model learned from long-term trends and was validated against recent market conditions, enhancing its adaptability. Next is the metrics evaluated. The LSTM-CNN model achieved a strong performance in RMSE of 0.1012, MAE of 0.08, MAP of 10.22%, and R-squared score of 0.4199 with tight 95% confidence intervals and a p-value of less than 0.05. These results confirm the model's reliability and statistical significance. For the baseline model comparison, three traditional models were used for benchmarking. First is the SVM, which is good for classification but limited in regression. Random forest strong in raw accuracy and robustness, and Araimas is best for simple and interpretable but weak in handling nonlinearity. Each model serves a distinct role in evaluating the hybrid's performance. Next is the results of using Ensemble. By lowering your RMSE and MAE by roughly 15 to 25% and increasing R squared by more than 2 times, Dallas TMCN and Ensemble demonstrated greater explanatory power and durability than individual models like SVM and Arima. The hybrid model, which combined CNN's capacity to identify short-term localized patterns with LSTM's capability in capturing long-term sequential dependencies, produced a better balanced forecast even though random forests had the lowest raw error. This integration eliminated bias in trend capture and decreased volatility-related mistakes, reducing MAPE from 7.81% ARIMA to 10.22%, making the hybrid technique more dependable to integrate stock market dynamics. Next is the visual presentation of findings. This table highlights how the hybrid model outperforms SVMs and ARIMAs in reducing errors and improving explanatory power, while random forests achieve the lowest raw error but lack sequential learning capabilities. Next is conclusion. The LSTM-CNN model significantly improved S&P 500 forecasting by integrating deep learning strength, while random forest showed how strong accuracy the hybrid excelled in trend detection and volatility handling. Challenges like overfitting remain, but future enhancements such as sentiment analysis Macroeconomic indicators and reinforcement learning could further boost model robustness. And last is the personal insights. So the study emphasizes how the hybrid LSTM-CNN model, which combines CNN's aptitude for spotting short-term trends in LSTM with LSTM's capacity to capture long-term relationships, provides notable improvements in S&P 500 forecasting. Although random forest achieves slightly lower RMSE and greater R-squared, it beat SVMs and Arimas by lowering mistakes and better managing volatility. The hybrid's integration enhanced explanatory power and decreased percentage mistakes, demonstrating deep learning's applicability to intricate, nonlinear financial data. However, issues like overfitting and sensitivity to extreme market conditions still exist, indicating that in order to improve robustness, future research should include the sentiment analysis, ensemble techniques, and macroeconomic indicators. And that's all for this presentation. Thank you.